Hi and welcome back. Now we switch into English. This is the third session and it's called an AI Tech Deep Dive. In this presentation we will dive into the possibilities and challenges that AI could give us. To present and discuss above topic, we have Anders Nilsson, CTO at 365ED, and we have the researcher Kevin Hernández Diaz from Halmstad University. And I think we could start with you, Anders. Could you please tell the audience a little bit about yourself and your company and what you do?
Yeah.
Okay. I think we sit down. I think
Sit down.
Yeah.
Okay.
So much softer, I think. Yeah.
Yes, I'm the CTO of 365ID. I'm originally from Halmstad. I've been studying in Linköping for a number of years. And then I moved to different places, and I ended up back in Halmstad.
Yeah.
So I've been with 365ID for 5 years now, I think, and 3 years as the CTO.
Ah.
Yeah.
Interesting. Once a Halmstad citizen, you always come back to Halmstad city.
Yeah.
Okay. Okay, then we go to you, Kevin. Could you please tell us a little bit about yourself and what you are working with?
Okay, I'm from Spain, from Huelva. I did my bachelor in telecommunication engineering. So I've always been interested in signal analysis, pattern recognition. And after finishing my master degree, I got this offer for a PhD position at Halmstad University. The project is about computer vision and pattern recognition applied to biometrics applications. My main focus is on the eye region, not only the iris, but also the surrounding around it.
Okay, so how long have you been in Sweden?
4 years.
4 years. And you love the weather?
Well, I can live with the cold, but the problem is the rain.
Okay, thank you so much. I think we'll go back to you, Anders, and perhaps you could show us a little bit about your company, 365ED, and what you are doing.
Perfect, I will do that. I have a small presentation.
Yes, welcome to the table.
Thank you.
Now we'll take your place.
Yeah. So, hopefully you will see the presentation. Yeah, there it is. This is quite new. We have tried to remake the presentation material for the company, and our marketing department, they are doing a lot of new fancy pictures. A little bit about 365ID, just a few numbers. It was established in 2015 by a man called Johan Hagelin. He is now the CEO of the company. You will see him in a short video very soon. And we are doing a scanner that identifies and verifies ID documents. It can be a driver license, passport, another ID document, or whatever. And it's documents from all over the world. We have about 1,600 documents right now, and it's increasing all the time because there comes new documents into the market every day. So we have one department that just works with adding new documents all the time. I think we cover about 99.5% of all the documents used in the world. And with that, we have 4,200 scanners at different locations in all over the world. And it's a cloud-based system, so the intelligence is not in this one. It's just a camera with different lights. And when we insert the document, we take pictures, and then we put them together in a package, sends it into the cloud to our servers, and that's where the magic happens, where we check what document it is, and then we have this document database. Then we can get what kind of security features do you have on the document. Is it something in the invisible light? Is something in the visible light, and so on? And then we check all of that to be able to tell the customer if it's a genuine document or not. Our office is up at Slottsmöllan here in Halmstad. We are now 14 people, I think. We added 3-4 people just recently, and we are perhaps looking for more people. I will come back to that at the end. And our production is in Sweden. The plastics is done in Sweden. The boards that is special for this, the electronic boards, is made in Sweden. Of course, we buy components and some other things from other places, but the production is in Sweden. So we have full control over the production. Yeah, where do you use the scanner? Banks, of course. You want to know if it's the customer that you have in front of you, is that the right person? Telecom, where you sell the phone. You can get the phone directly over the disk without paying anything. Of course, you want to know who it is on the other side. Car rental, you lend out the car for 300,000 Swedish crown, 400,000. And then, of course, you want to know who it is that you leave the car to. And then we have logistics, car dealers, government, hotels. It should be easy to install. It only needs internet. Right now it's through my phone, Wi-Fi, and you need power from a power bank right now. So it's easy. You unpack it, you plug it in, and then it's up and running. That's one of the ideas with this, that it should be easy. All other solutions that have been done before, it's a flatbed scanner, you should have a PC, you should have software installed on the PC, and you have to update the software and so on. Now we do that, we do all of that for the customer. You get it in the box, you plug it in, and you can check the first document after a few minutes. We can also check external databases, like the driver license database in Sweden, for example. That's one. Then we can send a question to them, and then the result is included when we present it on the scanner. So if your driver license is lost, for example, then it will be a red light instead of the green one, even if it's a genuine document, because you could find it on the floor somewhere or whatever, and if you look like the other person, then you can use it. We transfer the data into the customer system, of course. If you have a rental system, for example, you just insert the driver license, and then it will be your form that you will have to complete before you can rent the car. Then that is filled out automatically. Yeah, very cost effective. It's probably a fifth of what that cost before to rent this. It's just like renting what we call a mobile phone. If you pay 300 kronor perhaps for a mobile phone each month, this is the same area. Okay. I've been talking about the scanner, of course. It verifies documents. It checks that it's genuine. Of course, it checks the data on the document as well. If it's expired, for example, it's still genuine. It's a genuine document, but if it's expired, it's not valid. We can check to other databases. We save the data. We transfer to the customers, as I said before. And this is what it looks like. You have the scanner. You can insert the document. Perhaps we should start with the real one. I have a Swedish ID document. We insert into the scanner. Then it finds out something is happening, so it turns off the first light, and then it takes its pictures. And then when the pictures are taken, it will compact it into a package. And now it's uploading the package to the server, waiting for the result. And something happened with the system. This is the presentation demo. You should have a green light. No, there was one green light, but it shouldn't. We have to try it again. I will finish talking, and then we should try it again. It worked before. I don't know if it has with my phone to do it. And then why would we do this AI project? That's a question that I got before. So I asked around a little, why did we do this? Because I didn't remember at first. But of course, we wanted, the whole team was interested in AI. and no one had worked with it before. So there were a lot of interest among the developers, from our CEO, from the marketing. Could we use this for something? So we think, yeah, perhaps it could do something, because we have a number of processes that we do when we check the document. And also Johan had some thoughts about, could it improve the experience for the customer? Could it be faster? Can the system be faster? Can we do new things with it? Can we find new threats perhaps? And also what new functions are there that we can do? Now hopefully the scanner will work. So a little bit background about what Kevin should talk about, because he's going to talk about, we found one area in our system that this is something that we can try to applicate AI on this one. Yeah, now it worked. It's green. Hopefully this is a fake. I think you should see that this is a fake, but there are better ones. Plastic cards. Perhaps someone, if you gave this to someone at the post office, they can, yeah, it looks almost like a document. So what do we do when someone inserts something into the scanner? Yeah. Well, first of all, is it an ID document? There are a lot of them. You have passports, you have driver licenses, ID documents, all different kind of documents. Sometimes someone inserts a library card. So the first thing we have to do is to check what kind of document is it. And then when we have done that, we are checking the different images that we have taken. Yeah. Red light for the forgery. And then you have ultraviolet light. There can be a lot of different patterns with different lights. Normally it's blue, red, green. I think that's the most used images. And then if you have infrared, then when you have used infrared light, you get a black and white image. And if you have a real document, it would look like on the left, where you have this lady. And at the left you have the white image, and on the right you have the IR image. So that's a genuine document. Then the IR information, the information in IR is visible. But on a fake document like this one with our CEO, then it's blank in IR. If sometimes they have some information, but they don't know what the information should be there. So it's a way to see that it's a fake document. Okay, so what happens when we insert the document? This is very technical, so we just take it very quickly. The camera takes an image that we call with a scan, and then it's uploaded to the servers, and then we correct the image so it should be as good as possible. It can be inserted in different ways. So then we turn it around so it's always in the same way. And then we must say, what is it? Is it it's a passport or an ID document? That we can see that on the size, of course. So that's one way. If it's this size, then we can throw away all ID documents and driver licenses. But then we still have a number of ID documents where we would like to see what document is. It's a Swedish passport, German passport, or whatever. And then we do today we have some kind of machine learning where we calculate different checksums, sort of say, and then we store that checksum for each document, and then we can make a checksum of the document that comes in, and then you can, by mathematical methods, you can see which document is possible, the one that we are looking for. So you get a different number for each. It says this is the most likely one, this is the next one, the next one, the next one. And then we start to, when we have this list, this ranking list, then we try do an exact compare. Is it this document? Is it this document? Is it? So if we are not good at this, then we have to look through all passports perhaps before we find the right one. And also if it's a new passport that's not in our system, then we have to go through all of it. And that can take a lot of time to do that. Normally, even if we do that today, it takes between half a second and perhaps several seconds. So that's something that takes time in our system. But then when we have identified the document, then we can go in to see what security details there should be. So it can be traffic marks, it can be the different patterns that you saw here. And then we can make an assumption if it's a valid document or not. And then we read all the texts, of course, name, expiry dates, everything. And then we can check the expiry date as well. That's the process for this. And then when we started this project, we said, what should we look at here? And then we found out that the ranking is something that Kevin and his team could help us with, to see if there is a better way to do this. If we with AI could see quite quickly identify that this is a Swedish passport or a German passport or whatever. And what type, even if you're looking at German passports, you can have 5, 6 different ones. So there are a lot of documents. Yeah, this is something like that. We have a lot of what we call definition. That is what describes the different documents. We have the one that we have scanned. We have the ranking process. And then we get the ranking list. And in this case, the one that we were looking for was on the second place. So first we compare with that one, and then we will find out, no, it's not the same document. If we compare those two, yes, it's the right type. And then we can go on in the process. And then we have a small movie from our CEO about the project. It's in Swedish, so hopefully you will understand something. The people that don't understand English. Most of you are Swedish. Questions later on?
We can take the questions
Yeah,
after...
If there are anyone.
Yeah, we can take that after the movie.
Okay.
Yeah.
Okay.
Vi har tidigare jobbat mycket med machine learning och ser ju artificiell intelligens som det nästa steget för bolaget. Det kommer vara otroligt viktigt att vi bygger smarta lösningar, intelligenta lösningar som effektiviserar både vår utveckling och vår produktion. Projektet har hjälpt oss att komma igång med vår AI-resa. Det här har varit startskottet för någonting som ska vara en naturlig del av vår fortsatta utveckling. Det har varit väldigt inspirerande för mig, men framförallt mina medarbetare, att komma in i tänket, nya tekniker, och nu har vi fått en fungerande prototyp som vi håller på att utvärdera och testar, och förhoppningsvis så kommer den implementeras här under hösten i vår produktion.
Okay.
Thank you. Just one question. That scanner, that is only for driving license or IDs, not the passports, or?
No, it's for passports as well.
Where do you put the passport?
If you have a passport, you saw that I placed the driver license in the upper opening. If you have a passport, you'll find out the page that you would like to scan. Insert like that. And then we take a picture of the passport.
Now it will be red. No.
Actually it will, because it's expired document.
Okay. Yeah. So you have both for all kinds of IDs, I guess. Passports.
And even if you're looking at Italy, for example, they have different odd size documents. Then we have to actually have a kind of envelope with a screen. Red. With a glass in the front and the plastic in the back, so you can open that, put the document inside, and then it will have the same size, and then you can insert it into the scanner as well. So we take different sizes as well.
Perfect. I have one question. You did a project very much as a team effort. What was your thoughts about that?
What do you mean as a team?
Yeah,
We wanted to include all our developers to see what we could do with AI.
Yeah.
So everyone was included in the project.
Did you know what you wanted to use the AI for, or
No.
did you know? So
No.
you entered the project and said, okay, we want AI, but we're not sure where to use it. Okay.
Correct. Yeah. So everyone have heard about AI.
Yeah.
Of course, and there were different knowledges, and some have looked into it a little bit, but we didn't know what we could do with it.
Okay.
So it was kind of a first step for 365 ID to see where can we use AI, how do we use it, how does it work.
And now you have a prototype. I'm always talking about the time frames, but do you have any idea where we are in the process?
Yeah, you heard Johan said that he wanted it to be in production this year.
So it's very near.
It's not going to be that.
Okay.
Quite honest, we have a different. We have a kind of wish list with a lot of things. But right now we are developing a mobile phone application that you can use instead of the scanner. You can take the different invisible images, but you can check in many new documents. If you have this little symbol, then there is a chip in the document that you can read, and you can verify that data in that document with what should it call, the manufacturer of the documents.
Okay.
So you can be really sure that that data is correct. So the scanner reads that as well, and you can read it with the phone. So if you take an image and the image in the chip is it's the same as the one that you took on the document or on the person and so on, then you can use that data as well. So that's what we are working on right now, this app.
Interesting.
So it's from this wish list. I'm sorry, but AI is put a little bit down on the list, but we will do it. And there are some thoughts about looking at it in the beginning of next year.
Okay.
Yeah, because we saw that the result was very interesting, so it could be useful for us. Maybe we run it in parallel with the process that we have today, and perhaps you have two lists where you get this ranking.
Okay.
And then we can do a compare in production to see which method is the best, and then we see if we should merge them or if we use one of them.
Okay.
So that will happen.
Interesting. Anna, do you have any question from the side?
Not right now.
Not right now.
Okay.
Then we thank you a lot, and I think we will leave the stage for Kevin, because you have been one of the researchers that have looked into the possibilities around improving the 365 ID scanner with new IE techniques.
Yeah.
Your work has resulted in a successful solution for the project, and could you please explain a little bit more?
Okay, so what I'm going to present is basically part of the demonstrator that we developed for 365 ID in collaboration with, of course, High5. I'm not going to go very deep into the actual results of or any kind of the code of the demonstrator, but I'm going to explain how I guided the process and the proposals that I have for them in this particular task of ID ranking, the ranking system. Okay, so as Anders said, this is basically what we tackle onto in this project is the ID ranking system. Is, as he said, the very first step in this ID validation system. So basically the idea is, as he showed, you put an ID in the scanner, and the scanner, the ranking system has access to the images taken by the scanner and a rank list with all the possible IDs that they have in their database that they can validate. And the output is basically a rank list where organized from the most likely to the least one. one of the most interesting thing for me in this demonstrator was actually that this is actually not a critical step into verifying the ID. Since I work in biometrics, having the certainty that the person is the one in the picture is the most crucial part. However, this step does not invalidate the whole process. You know, it would only take more time until they go through all the lists until they found the ID that it is. So this is just a way to speed up the validation process and improve the user experience of the consumer. So the current system is basically just a combination of traditional image retrieval algorithm and detection and recognition of a region of interest around the IDs, and then try to find the best match. So the goals for this project was, can we improve the ranking system with more novel AI or machine learning solutions? And if so, can we do so with a similar or better speed than the current system? Because if it takes more time to actually do the process, it makes no sense. And they were particularly interested into deep learning solutions. And I can understand why, and it's because deep learning, or when applied to image, CNNs for image recognition, have actually proved to be one of the best tools to use. It has become basically the standard in any computer vision pattern recognition scenario, and they achieve a state-of-the-art in most of them. Also, their self-learning capabilities makes them actually quite flexible to train and to develop into new areas. Just as long as you have data, you are most likely to be able to develop a system using them. However, as awesome as they don't come for free. They actually usually requires a big amount of data in order to properly train a system and actually get top performance. And they are also usually much more computationally expensive than traditional computer vision algorithms. And finally, they are very limited in terms of interpretability, which in this particular case was that last one was not really a big of an issue. So as Anders showed, this is the kind of data that they get from the scanner. They get an image in visible light or white light, one in ultraviolet light, and one in infrared. The one in visible light or white light are the standard images that most of the CNN solutions actually work with. So they can actually be used, as a default for the problem. However, I was mostly interested into the ultraviolet images because the purpose of CNNs is actually extract meaningful features to actually recognize the ID. And this ultraviolet image actually has much more freedom into how the countries can make this stamp of validation for the IDs. However, it was a big of an issue because not all IDs that they actually are able to recognize have UV patterns. So if it comes into place, they will have to find an intermediate solution. Finally, the infrared image actually is not very good for this particular task because either they remove most of the actual features that you can use to recognize, but the features that are left are actually the ones that you should ignore when recognize the ID, which is basically the personal information of the user. So at the end, we end up with these two types of images, and one of the best things that 365 ID has in their system is that they constrain the acquisition scenario to the one in the sensor. So it is actually very easy to normalize the images based on illumination, orientation, scale, which are actually one of the weakest points when trying to recognize images using AI. So because of this, normalization, we can actually simplify the architecture of the network to optimize the speed instead of the recognition without having a big drop in the recognition performance. So a typical convolutional neural network is nothing else than a sequential set of filters applied one after the other in order to extract the meaningful features to be able to recognize or classify the image. As I said, one of the main advantages of this type of solution is the self-learning capabilities. As long as you can have enough data to train, the data is useful for the task that you want, and you can express your outcome as a possible option. So, and the normal output of a CNN is basically just a list with a certainty or a probability that the input image is actually belong to one of those classes. So the first option that I gave them is actually use a default CNN. I say default CNN because it's the actually default scenario, default training system that one that start with the CNNs actually use. It consists of just a set of sequential convolutional layers, and at the end, a softmax activation function that basically transforms the features that it extracts into a probability-like vector. And you basically optimize this process with the cross-entropy loss, which basically measures how different is the actual output that you want from, or you expect from the system, and the output that it gives. Of course, the structure of the CNN can be quite flexible, and it mainly depends on the complexity of the task, the type of data, and the performance or speed that you want. And as the input, it can be actually any of the image that they capture with a sensor or a combination of them. You know, it can be both white light and ultraviolet at the same time. It can be the white in grayscale and the ultraviolet in RGB. It can actually have two inputs and process both separately, however they want. However, this comes with a set of pros and cons. Pros is a very simple and effective object recognition model that is widely used, and they can have access to plenty of tutorials and networks to use out of the box to implement their solution. However, one of the main problems with this is that the database of 365 ID is highly mutable, meaning that, as he said, every day or almost every day, a country will actually launch a new ID that they want to add to their database. And the main problem is that this structure is more or less fixed. So if you want to modify this output, you will have to go through a retraining phase. And this is actually one of the issues because due to GDPR, I'm not an expert in this matter, I'm not a lawyer, but I assume that it will have some kind of restriction into storing all the information that they get in the servers. And also another problem is that since the company is Swedish-based, the data distribution will actually be unbalanced. They can expect to have much more Swedish and European IDs than, for example, Americans. And this will have to be taken into account when training the network, because otherwise the network will try to say, okay, 9 out of 10 IDs is Swedish, so I will say Swedish by default and hope the best. As I said, then for the training case or the first training part, they will only can't rely actually on the specimen dataset, which is these kind of fake IDs that the government launch to use this kind of system. So yeah, it's a bit tricky. This is one of the other solutions that I propose. I'm a big fan of Siamese networks. especially triple loss networks. And the point of these networks is actually to create a feature vector at the output of the CNN that, that can be used for recognition. The only difference from before is that you don't want to create directly this list of most likely to less likely classes in your database. You actually want to basically minimize the distance of this feature vector that the networks create of the reference image, whoever person ID is put into the scanner, to the reference image that they have for that particular ID in their database. And maximize, at the same time, the distance between the input image and any negative class in their database. So as you could see in the picture below, before, you virtually have three different networks. But since they are Siamese in the sense that they all share the same weights, you can exploit this to improve the training process. The loss function used to optimize is basically that function, which basically try to minimize the distance between the reference and the positive case, while maximizing the distance between the reference and the negative case. But one interesting thing is that once it actually reaches a specific performance, basically, once the distance between the reference and the positive case plus a margin is greater than the distance between the reference and a negative sample, it will stop training. And this is actually a good thing because it will lead to fewer problems in the long run. I think I will go back to that in the next slide. And now, but the problem is that, before you had, the first case you had one image and now you have three. How do you deal with this? Well, they now have to come up with a new strategy to select what type of images to select. And this is usually based on a similarity score between the reference and the classes. In order to actually be able to select hard cases for the network and optimize the training to recognize these challenging scenarios. Because otherwise, you can create a lot of combinations that the network is actually pretty good to recognize. And so the gradients when optimizing is not going to be that good. They will basically slow the training process and is likely the network to be stuck in a local minimum. But now for deployment, even though here appears as three networks, for deployment you only have one. This is basically because you will pass this image to the network, extract these features, and then compare it with the list in the reference database, and then organize this list based on the from closest to farthest. Now, again, these are some pros and some cons. The pros is that now the mutability of the database is not really that big of an issue because they can actually add these new IDs in the triplet selection strategy. So the network will automatically include them to create this triplet and use them in the cases that is more challenging or more problematic. And as I said before, the imbalance problem is not also that big of a deal because once reach a certain performance, if the distance between the positive case is much greater than to the negative case, it will not use that triplet for training. Now the cons is that now we make the computational process much more expensive, and we need a new strategy for triplet generation. And now we have parameter alpha or margin to define. Other possibilities that I talk with them is with deep learning, it can be autoencoders. Autoencoders are just a network that tries to compress the input into a much reduced latent space and then construct it back. Of course, they don't care about the constructed back part. That is only for training. But after training, they can take this reduce a latent vector that contains global information about the ID and use them for classification purposes. And I also recommend some other traditional computer vision pattern recognition algorithm, like SIFT or HOG for feature extraction, and combine it with the algorithm that they already use in using a machine learning model like logistic regression, which is a smart way to combine results based on the performance of each of the systems. Last remarks about the benefits of using the raw scanner. Basically, the data is normalized, and they have all this continuous streaming of information flowing through their service that they can use to actually train the system. The specimen database is actually a bit problematic because you only have one sample, and you have to guide the network to not use the features that, like for example, the face information that they contain or the name and so on. But they can apply some strategies to this, for example, masking out the regions that are problematic in this sense, and they can actually use the infrared image to automatically create this mask. As I said, CNN models are actually quite flexible. As long as we can define a differentiable loss function and the data is useful for that particular task, we can actually define this kind of architecture. Another thing is that, as I said, CNNs can have different inputs and different outputs, so they can extract some other information at the same time that they do a feed forward through the network. For example, not only create the ranking list, but also extract some other information, like they detect there is a Swedish ID, is a driver license, or so on, that they can actually use to guide also the recognition process. About the speed problem, which is one of the main issues here. CNNs are computationally expensive, but they can rely on GPU acceleration to actually reduce the computational time by quite a lot. During the demonstrator, I calculated the average prediction for an image using the ResNet 50, which is what I use in this demonstrator. And my GPU was an NVIDIA RTX 2070, and the usually feed-forward process was about 50 milliseconds. So is this good enough for them? I cannot really say. They are the ones that can say it. Thanks to the sensor environment, the task can be the complexity of the task is highly reduced. Right, so they can go for much cheaper models or smaller models that can be actually much faster than a big model with a slightly better performance. So to finish, as I said, CNNs are actually quite powerful and versatile tool in computer vision pattern recognition that can be used in many different applications. 365 ID actually have the tools and the ideal environment to actually exploit these tools to not only improve their own system, but actually expand with it, because they have access to a lot of data. They have a normalized scenario. They can either buy or rent the computational power to run all these experiments. And one of the main issues with the CNNs is actually the interpretability, but in this case, it's actually not that big of an issue. And as I said, one of the interesting things here is that they are not. This is not a critical or process, so it can be quite flexible with it, which is the ideal scenario for this kind of probabilistic stochastic methods. So just to finish, the most important things to analyze when developing an AI system is analyze deeply the data. What are the features that you want to extract? What are the features that you want to use? And understanding at least just a bit about the model, what it does, in order to align those two. And then know your needs. Is speed, is interpretability, is performance. All these will guide your solution in this sense. And that's it.
Yeah, do we have any questions from the side?
Not from the side.
Not from the side. I see that we're actually... thank you so much, Kevin. Very interesting. Yeah. I see that we run out of time. I know if there is something more you want to show. Otherwise...
It was just a little bit about what we talked about before. Is this that when are we going to use this and how?
And
so I think we have answered those questions
we took that before.
Yeah. So it's something that we really appreciate your efforts. It's something that I think we can use this, and you said this is 50 milliseconds fast enough. Yes, it is.
And it will come at the beginning of next year.
Yeah, hopefully. Now we made that on a small number of documents. We have to, of course, test it on all of our documents and see what happens. But and then also having more power resources with faster computers and GPUs and so on. That's available in our cloud. So we use the Azure cloud to run all our services, and they have GPUs and whatever. It's a cost question, of course, but 50 milliseconds, then we can handle a lot of documents each second.
Yeah.
So that will be fine.
Okay, so thank you so much, Anders, and thank you so much, Kevin. I just want to thank everyone and high five and the University of Halmstad to have made this session possible. If you have any further questions regarding AI or AIM, there will be more information in the chat. Anna will present every telephone numbers and emails and everything. So thank you so much for listening. You out there, you in here, thank you and goodbye. Det går så jäkla fort när man har skoj.